Hey everyone, it's SpaceBat. Here with some exciting news about an event that will happen in the sky sometime between now and September, and also a little information about white dwarfs. This event will be a chance to see a nova. It will not be quite as bright as a supernova, but it will still be visible to the naked eye for about 1 week. If it is a clear night for stargazing, look for the Northern Crown, or also called Corona Borealis constellation. It is between the Hercules constellation and the Boötes constellation. Astronomers happily announced that in a binary system located 3,000 light-years away, that includes a red giant star and also a white dwarf star known as T Corona Borealis b, or Blaze star. Every 80 years puts out a spectacular show. The white dwarf in this binary system has been alongside another star since their formation. It is comforting to know, in the vastness of space, that some stellar objects are not alone. The dance partner is called T Corona Borealis A, which is a red giant that is being stripped of its hydrogen as it nears its final phase of becoming a white dwarf like its partner. This hydrogen is then siphoned off by the white dwarf onto its surface. This extra heat and pressure build up until a full-blown thermonuclear explosion happens. The surface of the white dwarf explodes like a fusion bomb, making the star visible to the naked eye despite its distance to us. The explosion will be so large that the resulting glowing plasma ball will be visible for days. Hope everyone can catch a glimpse of this once-in-a-lifetime sight. Now let's go on an incredible journey to explore the fascinating endgame of the stellar evolution of a white dwarf, which also includes our own star, the Sun's fate. Stars like our Sun spend the majority of their lives in the main sequence phase, burning hydrogen in their cores. As they exhaust their hydrogen fuel, they begin to swell into red giants, marking the start of a dramatic transformation. In the red giant phase, the core contracts and heats up, igniting a shell of hydrogen around it. This increased energy output causes the star's outer layers to expand and cool, giving the star a reddish hue. If the core temperature becomes high enough, helium fusion begins, forming carbon and oxygen. This phase can be stable for a while, with helium burning in the core and hydrogen burning in a surrounding shell. After the helium is depleted, the star enters the asymptomatic giant branch phase, with an inert carbon-oxygen core and shells of helium and hydrogen burning. Intense mass loss occurs, expelling the star's outer layers into space. When our Sun reaches this phase and swells up as large as it can, it might expand all the way to Mars. We'll need to find a new home before then. This mass loss results in the creation of a beautiful planetary nebula, a shell of ionized gas, glowing in the light of the exposed core. What remains is the hot, dense core. No longer undergoing fusion, the core contracts and stabilizes as a white dwarf, supported against further collapse by electron degeneracy pressure. A white dwarf is a fascinating object. Roughly the size of Earth, but with a mass similar to the Sun, it is incredibly dense. A single teaspoon of white dwarf material would weigh tons on Earth. Happy to know it won't end up as a black hole, but a white diamond in the sky. Wouldn't it be unique if when a man proposed, instead of a diamond, it was a white dwarf? Over time, the white dwarf will cool and fade as it radiates away its residual heat. Eventually, it will become a cold, dark, and inert object known as a black dwarf, a fate our universe has yet to witness. Our universe is thought to be around 14 billion years old, and it's theorized that a white dwarf could take between 10 to hundreds of billions of years to cool off enough to become a dark star, emitting no energy. Researchers at NASA estimate that 97% of the stars in our own backyard of the Milky Way galaxy will end up as white dwarfs. A little background on the first white dwarfs discovered. It was in 1862 by Alvin Graham Clark, who noticed a faint glow next to Sirius A. He observed that Sirius A wobbled slightly and discovered it was another star, a white dwarf, which was then named Sirius B, or by some affectionately, the pup. The ancient Greeks had observed Sirius A when it was just called Sirius, but later the A was added when the white dwarf was discovered. Since the discovery, over 10,000 white dwarfs have been discovered. White dwarfs are the silent remnants of once vibrant stars, a testament to the incredible life cycles of these celestial bodies. They remind us of the dynamic and ever-changing nature of our universe. Join me next time. Thanks for watching.